the student advisor to be available in the Archana Tanavade madam, please occupy your seat. Ramesh Kulkarni sir, we request you to please occupy the dais. Please sir. A very warm welcome to one and all present here. We all have gathered here to celebrate the Concrete Day event. I request all my dear students to please have patience and silence. I am very sure you all are very much tired with the entire event and everything. I expect a little more patience from you guys. Thank you very much. We have a lot of eminent people here who are going to share their expertise and experiences with you, which will in all contribute to your lives. So please be patient. Thank you. A very warm welcome to one and all present here. We all have gathered here to celebrate the Concrete Day. And this event is jointly organized by Indian Concrete Institute Pune Center in association with AICTE DT, and the convener of this event is Akhil Bharatiya Maratha Shikshan Parishad, Ananta Pawar College of Engineering and Research, Parvati, Pune. The formation of the Indian Concrete Institute was on 7th September, so this day is celebrated as Concrete Day. We are opting the celebration of this day today. So this is a platform to create a motivation in the students to explore their talent and to gain insights from the events conducted in these 2 days. Already there are few events conducted today. I will just read out the list of events which are going to be conducted tomorrow as well and have been conducted today. Exhibition of construction equipment related products, admixtures, national level competitions which are tech search, paper presentation, tech concrete tube competition, tech poster presentation, tech ice cream stick bridge model making, tech green concrete cube competition, tech innovate ideas competition. These events are for all the degree and the diploma students of various fields, especially for civil department. Now we have a small audio visual prepared by Indian Concrete Institute. I request my technical team to please play the audio visual. And I request the students to be patient and watch the audio visual.
Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder and the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals and organizations involved with concrete. A non-profit organization, ICI is dedicated to the cause of disseminating knowledge and address constant research needs on concrete as well as to promote concrete technology and quality construction. In 1982, SERC Chennai and Anna University jointly conducted an international seminar on modern concrete construction practices. The delegates of the seminar resolved to form an organization to share knowledge so that developments in concrete could be shared with many Indian engineers, and the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body, having more than 12,000 enrollments from 38 local centers spread across the country. Of these, more than 256 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its local centers, conducts a variety of programs like seminars, workshops, conferences, exhibitions, and training programs, etc., each providing the participants platforms for learning and interaction at national and international level. Each ICI event is a unique opportunity to listen to and interact with all segments of people in the concrete industry and get updated on the latest materials, technologies, and practices. Many events are focused on sustainability through the use of innovative materials and techniques. The response to such programs from government bodies is overwhelming. The objectives of ICI are clearly defined. Every action of ICI focuses on a tangible output for the benefit of practitioners, end users, and society at large. On 7th September every year, Concrete Day is celebrated as an annual event at all centers in a big way to commemorate the day of formation of ICI. Working in close coordination with central and state government bodies like CPWD, PWDs, municipal corporation, etc., ICI helps these bodies to adopt the latest technologies and practices in infrastructure building. ICI members also participate actively in several committees of BIS. Focused towards advocating the concept of sustainability in construction practices, ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of 10 Asian countries. ICI has signed MOUs with many other concrete institutes around the world for exchange of technological information, technical documents, and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through students' chapters. There are more than 165 students' chapters all over the country, and the numbers are constantly increasing. Each chapter is focused on bridging the gap between basic theoretical knowledge and professional practice by imparting requisite knowledge to budding engineers. ICI identifies, recognizes, and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To disseminate knowledge, ICI brings out several publications with the help of technical committees for the benefit of practicing technocrats. Its journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. It stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering
Mukunda Datta sir, Chief Quality Assurance Expert, General Consultant, Pune Metro Rail Project. I kindly request respected engineer Ramesh Kulkarni sir to felicitate our honorable chief guest of this event, Engineer Mukunda Datta sir, Chief Quality Assurance Expert, General Consultant, Pune Metro Rail Project. We welcome you, sir. Students, please be seated on your places. All the students.
We get the participation certificate. So please be seated. All the students are requested to be seated.
Thank you, sir. Now, I would like to request respected engineer Archana Tanode Madam, Executive Committee Member, ICF Pune Center, to give a brief account about concrete day.
Good evening, respected dais, of the dais, and all engineers. Very warm welcome to all of you. As we all know, right now, Madam has said that 7th September is called as the Concrete Day, and it is celebrated all over India, and that is the reason that these all events, it is organized by ICF Pune centers. I hope that everybody is enjoying that event from student side. I hope you know what is the event. That is a green concrete. That is a waste event, and we got many entries for the green concrete. So the theme is green, right? So what is exactly green concept behind this concrete? So green concrete is a revolutionary topic in the history of the concrete. Though it is much like the conventional concrete, but the production of such concrete require minimum amount of energy and cause least harm to the environment. So how we can achieve? By replacing the cement with the all cementitious material as like GGBS, silica fuel, fly ash. Also we can able to replace the sand, crust sand with the help of crust sand, and again manufacture sand right now it is in the market. Even if you want to prepare the green concrete, we can use the different waste material and we can reduce the burden on environment. So this concrete is designed in the various forms according to the need of industry. Every society, state, nation must be respective of the changing time and accordingly prepared to take challenges and opportunities that come with the change. While doing so, nature must be protected under all circumstances while preparing the concrete. In this, there are the two challenges right now we are finding. Number one, that is climate change and the biodiversity. Because the globalization, it is now the peak, right? And that's why this green concept it is ahead us. What is climate change? As reducing the carbon dioxide as the production of cement, to use the cement, we have to replace with the all cementitious material. So ultimately, we will be able to reduce the carbon footprint. So we can produce the carbon less by reducing the production of cement. What is the biodiversity? It is a critical part to the health for the environment that we can reduce by using the green concrete. So these two challenges, it is in front of you all generation, all the industry people, and that's why we have come with this green concept. So I hope you are enjoying this event. The cement and concrete industry has long-lasting commitment improving and enhancing this biodiversity in areas that it opens. Concrete has always given solution to the many construction problems, and also the research it is carried by all IITs, NITs and self-sponsored college with the help of all industry people. Hence, I appeal to all young generation to come forward and be a part of ICI family. You can take the membership, if you're organization, if you're corporate, if you're students, so you can go with the student chapter and come ahead and carry out the research in this area to make the concrete green. Last, not the least, be a part of solution but not the part of a pollution. That's it. Thank you so much.
Now it is time for a technical session. We have a technical session on green and sustainable products by JSW team, guided by respected Mr. Trivikram Shendvi sir, Vice President Direct Sales and Techno Marketing, GGBS Business for JSW. Welcome, sir. So please come on the podium for your dialogue. Please welcome.
Very good evening, ladies and gentlemen, and the senior engineers on the dais. It's a pleasure for me to be a part of this event and present to you about green concrete. A lot of my effort has been made, madam, by setting the context for this theme. Why green concrete is necessary, what are the effects of climate change, how the climate change is affecting all of us, and how the times are becoming more and more difficult. And if things are not focused towards green concrete, what more implications can it have on us as engineers? So to talk about it today, my presentation is on the same theme, that is strong, durable, sustainable, and green concrete construction. I'll skip some of the slides because I have only 30 minutes. So I'll skip some of the slides on the corporate thing. You can refer our website to understand more about the JSW group. And I'll come to the products. So if you look at this portfolio of products that we manufacture, a bulk of the products are green cements, composite cement and slag cement. We are the pioneers in the manufacture and marketing of GGBS in India, and we are also the country's largest producer of GGBS. Apart from that, we are also into alternative materials like slag sand. Dr. Archana mentioned about use of alternative sand also. So we also manufacture slag sand, which is again a green material. So why concrete is very, very important? We all know that just after water, which is a naturally occurring resource, anything that is manufactured, concrete is the largest consumed material. More than 14 billion cubic meters of concrete is produced annually around the globe. And that acceptance is so much because it is very easy to make with the local available materials except for cement that comes from a factory and maybe the admixtures. Everything like the fine aggregate and coarse aggregate are locally sourced. So it is possible to make a fairly good concrete at the site with locally available material. You can design it into the shape and architecture what is required, different spans what is required. So that is why concrete has gained so much of acceptance. However, having said that, we are a part of the industry that is contributing about 7% of the total carbon footprint to this globe. And that is why our role is very, very important in times to come. As you all know, India is the second largest cement producer with close to about 340 million tons capacity. And with the growth that is, with the thrust that is there on the housing and the infrastructure, I'm sure India will start touching about 550 million tons by 2025. All the cement companies are on a major expansion drive, anticipating the demand which is underway. So how can we make green concrete? The context has been said, I will skip this slide. My presentation will be focused on use of mineral admixtures. So I'll talk about GGBS, ground granulated large furnace slag, IS code, relevant code for this is IS 16714. So, how does the journey start for slag? You would have seen in the slide that I skipped the first slide, that we are country's largest producer of steel, primary steel. There are two types of steel manufacturing. One is the secondary process, one is the primary process. So we adopt the primary process where the journey starts from the mines. We collect the iron ore from the mines, that is processed in the blast furnace, and from the blast furnace, using a blast furnace, we separate pure iron from rest of the non-iron materials in the iron ore. In this process, there is a byproduct which is liberated, which is called as granulated blast furnace slag. It is liberated as slag, and then it is quenched with jet of cold water to get a byproduct which is called as granulated blast furnace slag. Now this granulated blast furnace slag, unlike any other byproduct or a waste material, is very, very rich in terms of all its chemical composition. It has all the properties of a cement. Technically, it can be called as a 70% cement on its own because of the chemical components that are present in this slag. What we only do in our cement plant is grind this slag into a very, very fine powder and convert it into GGBS, which is ground granulated blast furnace slag, a replacement to cement. The code permits replacement between 25 to 70% based on the application, based on the durability requirements, based on the resistance requirements, and based on the performance that is required in the concrete. So what is this chemical reaction? We all know that the concrete hydration, the cement hydration reaction is such that over a period of time there is an initial set, after the water is added, there is a final set, there is a strength gain, and the strength gain is essentially because of the CSH gel, calcium silicate hydrate gel. This gel is something that binds the fine aggregate and coarse aggregate together to form an artificial rock, which is called as concrete. But at the same time, there is this calcium hydroxide which is liberated, which is a byproduct of this reaction. On its own, if it is inside the concrete, it is very good for the concrete because it will maintain the alkaline pH of the concrete and help the concrete to get a protection for the rebars. However, unfortunately, this calcium hydroxide is soluble, and many a times through the capillary pores, there is a tendency that water which can enter inside can dissolve this calcium hydroxide and come out of the concrete and make the concrete porous. That is why the challenge is that the focus is that we have to convert this soluble material into an insoluble gel, and that can be done by use of slag in concrete. A similar pozzolanic action can also happen by use of fly ash, and that is how the code allows replacement of fly ash between 15 to 25% because fly ash is pozzolanic. It has good amount of silica. A good fly ash has good amount of silica. But slag is such that it has silica as well as lime. So that is how this GGBS again reacts with this water, and calcium hydroxide also reacts, and then you have a action for hydration which goes on over a long period of time, and that is how the concrete continues to gain strength for a long period of time. That is how over a period of time the concrete becomes more and more strong, more and more durable. It also helps to reduce the heat of hydration in concrete because you can replace cement up to 70% as per the total approvals. So you have all the advantages that you require. You have higher compressive strength, you have higher ultimate flexural strength, you have better performance in terms of the reduced heat of hydration. So now I am told that the higher FSI is allowed in Pune. So buildings are going taller and taller. With that, the foundations will also at many places become raft foundations. So raft foundations necessarily require concrete with a lower heat of hydration so that the core and the surface temperature differential can be brought down. That is possible by use of GGBS. In Mumbai and Pune, we have a lot of examples where 60%, 65%, even 70% GGBS has been replaced for the raft. It has better resistance to sulfates and chlorides. So we have examples like the trans-harbor ceiling, we have examples like the coastal road where they require very high durability because the concrete is in a marine exposure, and they are using GGBS in a tune of about 63 to 65% to get a better performance. It has better resistance to corrosion. It is a green building material because you replace so much of cement from the concrete mix. It has better water impermeability and a better particle packing effect. So I will go to the case studies, some of the case studies which will be more interesting. And I'll start from Pune because we are in Pune. This is the example from J. Kumar site only in Pune. Yusuf sir is here and our general consultant sir is also here. So this is from Pune Metro, where in pile concrete M35, they approved a mixed design with 50% GGBS. The total cementitious for M35 was about 430 kgs with 215 OPC and 215 GGBS, and they were able to get the required strength at 7 days, not just at 7 days and 28 days. But if you can see the jump, it is almost 35 M35 concrete going till about 57 MPa in 56 days. In fact, Yusuf sir also did some study to understand what was the strength gain at 90 days, and I think it was very, very high. So they also use GGBS for the pier concrete for the columns, and they used 27% because they needed a faster de-shuttering time, and it was about 27% replacement, 400 OPC, 150 GGBS and 25 microsilica. They are able to get the required strength at early age, and over a period of time also there was incremental gain in strength. Some of the finishing, very good quality of concrete, very good finishing, homogeneous concrete, good cohesiveness, thereby leading to a good finish and good concrete. This is another case study where the environment was very, very severe. The underground metro project, line 3 in Mumbai, designed between Kulaba to SIPS, 7 packages, 5 contractors, all of them using GGBS for the last 6 years. More than 3 lakh tons of GGBS supplied in this prestigious project. This is one of the case study there, where 3 lakh cubic meters of concrete was the scope for the M40 slab raft, and the design life was 120 years. So to get the design life of 120 years, with a RCPT value not exceeding 1000 coulombs and water penetration values not exceeding 10 mm, they decided to use the GGBS with 45% replacement, 46% to be precise, and these were the strength gains. At 3 days they got about 25, 7 days about 41, and 28 days going till 64 for a M40 concrete. And in terms of the durability, you can see the WPT values against 10 mm, which was the maximum limit, they are able to bring it as low as 4 mm, which is a very, very good concrete. It is underground concrete, so it is essential that the concrete has a better WPT value, so that it remains durable for 120 years, which is expected, which is the design life of the structure. For the RCPT value, the average values were around 730 coulombs, which is again a very, very high quality concrete by using a mix of GGBS and microsilica. Another case study is for the Bangalore International Airport, Kevegoda International Airport in Bangalore, done by L&T. The recent expansion which was carried out was designed for a PQC of 5 MPa at 28 days, and the pavement quality concrete was designed with 40% GGBS for the first ever time. The PQC was designed with 222 OPC and 148 GGBS, and these were the values: 7 days about 5.2 MPa and 28 days 6.9 MPa. Very, very good. Another example of a marine exposure, that is the Cable Stayed Bridge at Goa, which is being done by Dilip Con. M55 pylon concrete for the raft, and almost 9,800 cubic meters of concrete ought to be poured in less than 3 days' time without a cold joint. And this was done very successfully by Dilip Con. M55 RCC, they use 50% OPC, 50% GGBS, no microsilica, no alcofine. They are able to get the values of 6 mm water penetration and 158 coulombs. Look at the strength, 28 days going till 75 MPa. And even with the 50% replacement, getting almost 55 MPa in 7 days. All that is possible. Very good admixtures are available. Our team is available. We can give the necessary support to the project sites to get the early strength, to get the long-term strength, to get the durability. And especially since a large number of students are also participating, I'm sure when you go to the sites, you'll know this product better when you start designing concrete. Another case study of AP Secretariat building at Amravati in Andhra Pradesh, where of course after the new government formation this project is stalled, but there were 5 huge raft foundations, which was almost like a record concrete done in India. Each of these concrete was close to about 11 to 12,000 cubic meters to be done in less than 3 days without a cold joint, and this design was done by IIT Madras and Center in Technology in Bangalore. The dimensions were almost like 52 meter by 52 meter by 4 meter deep, and to achieve such a deep concrete without having any issues of cracking, they decided to go with a 60% GGBS. They used Ultratech OPC for 53 at 185 kgs, JSW GGBS at 275 kgs. Concrete strengths, though the acceptance criteria was 56 days, they were able to get the strength within 28 days, and they were able to limit the temperature gradient between core and the surface to less than 21 degrees. Immediately after the concrete was completed, they covered it with thermocol sheets, plastic. It was wrapped so that there is no heat exchange. Because in the night times, Vijayawada was very cold. They did all this and ensured that the gradient issue was taken care. They were able to get the strength, they were able to get the required durability parameters also. This is already covered. Another landmark project is the Trans Harbour Ceiling in Mumbai, which is again designed for 135 years of service life, funded by JICA. And here they are using a replacement of almost around 58% above the water, 63% below the water to get high durability. Marine exposure, concrete in the sea, likely attack of sulfates and fluorides.
Can you have silence? They are giving the lecture, they give technical presentation, you should listen it. Huh? Keep a silence.
Thank you. So here some of the challenges were there. We have to plan the logistics in such a way because this is not a land-mounted batching plant. This is a floating batching plant inside the sea. So the batching plant is actually on a ship, on a barge. So even the raw material has to be converted by barge. So the barge will come with the silos installed at the shore. The material from our bulkers will be unloaded into it. The sand, aggregate, cement, everything will be unloaded like this. Depending on the high tide, low tide, this has to be carefully planned. Then the barge will go into the deep sea and it will be unloading the material into the batching plant and the concrete will happen. So this is the concrete in operation deep into the sea, and almost 70% of this project is completed by Tata and L&T, and very soon we'll have this project in operation for the service of Mumbaikars. So we also did a study with IIT Mumbai to understand how is the strength achievement at various levels of GGBS replacement, to get a feel if the early strength parameters are taken care or not, the later age strength parameters are taken care or not. So this was an apple-to-apple comparison for a concrete with 100% OPC, 40% GGBS, 50% GGBS, 60% GGBS, and 70% GGBS. And these are the strengths at 3 days, 7 days, 28 days, 56 days, and 365 days. This concrete was studied till 1 year. And this was the report. I'll run a bit fast on these slides. The most interesting thing would be to watch the 365 days. 40% replacement giving up to 95. Look at the pure OPC, it is stuck at about 67, and even a 70% GGB is going till 77. So any concrete where you don't require a very high early strength, especially a raft foundation or something, you can go with high replacements. For applications where you require higher early strength, we can design to choose around 35, 40, 45%. And then it was also studied for the other parameters like the flexural strength. Even with flexural strength, the 50% replacement gave the best. And that is why a similar study was also done at CRRI. And IRC approved use of GGBS for the concrete roads till 50% in 2017 October. The revision was published. We also studied the durability parameter, which is the chloride migration test. And you can see just by addition of 40%, the chloride migration coefficient, which is 6, drops to 0.7. That is the magic of using finer materials and supplementary cementitious materials like slag in concrete. We also studied at 56 days, and almost at 60 to 70% the concrete is almost like a rock. It does not allow anything to enter inside. So that is how today most of the specifications of the projects, wherever long durability is required, today GGBS is more preferred. And it is good that no more we are talking just about strength. We are also talking at the durability parameters. That has become a part of the specifications. That is a good thing because till now we are only designing for strength. Now if we design for durability, strength is of course going to come. So some of the other specifications of various prestigious projects where GGBS is among the approved materials. Certain very sensitive works like the Atomic Energy Regulatory Board also approve use of GGBS, the National Highways approves, MSRDC is approving, CIDCO is approving. So today there are a large number of IS codes, railway codes, MOR, and many other codes which approve use of GGBS in various applications. So we should take this in a very positive way, and this is going to help us to make green concrete. How it is going to help us make green concrete? This is a classic case of how our customers have helped us to make concrete green. This is the sales chart of GGBS that we have sold in the last 6 years. That way we have been selling for last 10 years, but this data only talks about the last 6 years. Whatever GGBS is sold in the last 6 years has converted into almost 83 million cubic meters of concrete. This 83 million cubic meters of concrete, since GGBS was designed in this concrete, it has replaced OPC from the mix by about 12 million tons. 12 million tons OPC using EVO because GGBS is here. And since 12 million tons of OPC was replaced, we are able to conserve about 1.07 million kilowatt hours of electrical energy. And you know, coal today is a very precious resource. We are importing a lot of coal, and a lot of foreign exchange is spent on coal. It is essential that we conserve our coal for future. We are able to conserve about 8.9 million kilocalories of thermal energy because OPC requires a lot of thermal energy to produce. Slag does not require because slag is only a recycled product. We are able to conserve, we are able to bring down the carbon dioxide footprint by almost 9 million tons. That has been the major advantage for the concrete that has been made with GGBS. And limestone, which is again a very precious resource for future. Today there is no other replacement to cement. We have to have cement. So limestone, which is very much essential for cement, we have been able to conserve limestone by 14 million tons in this 83 million cubic meters of concrete, which was made with GGBS. And if this slag was not used, it would be lying somewhere near our plant as a landfill. So it is a waste to wealth type of a recycling that we have been able to achieve. This is again a very interesting slide. M40 concrete. We have 3 examples. M40 concrete with a pure OPC 440 kgs. OPC plus fly ash 25% replacement with 480 kgs total cementitious. And OPC plus GGBS with 480 kgs total cementitious. We designed it to get almost equivalent type of a strength at 3 days, 7 days, and 28 days with almost similar type of a slump requirement. And these are the findings. You can see the strength levels are almost at par, which means that a concrete with 440 pure OPC behaves almost similar for the strength with 360 120 OPC fly ash or a 240 plus 240 OPC GGBS. Now, strength is something which will anyway achieve. Durability, we saw so many case studies, it will anyway achieve. What is more important is in line with the theme that we are discussing today. GGBS based concrete has reduced the carbon footprint by 42%. 42% compared to a pure OPC mix, and compared to a fly ash mix, it is reduced by 29%. This is the type of and this is not at an extra cost. The cost will be almost as similar to a fly ash concrete, or maybe marginally 50 rupees plus or minus. We can discuss it case to case and make it case specific, but then I am saying this you are able to get not at an extra cost. So what more do you want? You get your strength, you get a better durability, you are using a recycled product, you are getting a lower carbon footprint. Lot of companies have already started signing up for the pledges for the carbon footprint. Some company has said will become carbon neutral by 2035, somebody has said 2040, somebody has said 2050. And to do that, it is essential for all of us to make concrete with less and less cement, more and more recycled materials. And that bigger advantage can come by use of GGBS because it is more like a cementitious product. So we have gone one step ahead. Much before the Indian cement industry started even thinking about Green Pro certifications or the EPD certifications, we went into it. We are the first cement company in India to have the EPD certifications, and this is what it talks about. The global average for the carbon footprint is 608 kgs per ton of cement produced. The India average is 560, so Indian companies are much better than the global cement companies. Look at JSW Cement. JSW Cement overall is only 216 because our focus has not been on OPC, our focus has been on slag cement and GGBS. So standalone GGBS is only 60 kgs against slag cement which is 325. And you will be all aware that OPC is close to 910 kgs per ton of cement produced. So, if OPC is 910 and GGPS is 60, just by replacing 50%, it can come down by such a drastic number. So today, some of the most prestigious infrastructure clients are specifying and recommending use of GGBS. Some of the contractors who are using GGBS on a pan-India level, like in case of J. Kumar, they started in Pune, they liked the product, they used in Mumbai, they are now using in Surat. Now we are in discussions for use even in Delhi. So this is how the acceptance starts. Ready-mix concrete companies, even our competitor cement companies in the ready-mix concrete, today use GGBS to make green concrete. For example, ACC, Ultratech, Nuvoco. Some of the residential property developers also today who are focusing more on green concrete are preferring use of GGBS. Some of the landmark projects, the Ram Janmabhoomi temple in the raft, where they used a five material blend, they used GGBS, about 1600-1700 tons of GGBS was sent all the way from Mumbai plant to Ayodhya for this prestigious raft on which the Ram Janmabhoomi temple will be constructed. Also, another case of the Karwar Seaport project, which is the largest, Asia's largest naval base. One of the very important projects for the Indian defense. Some of the marine projects like the coastal road, the underground metro, and even the tall buildings like the Oberoi Sky City in Borivali and Goregaon. There are not many other examples. Even in Pune, we have Shapoorji Pallonji, who is among our leading customer using GGBS on a very big scale. We have Dilip Bitcoin, we have L&T, we have Tata Projects, and we also started making ready-mix concrete. We also started coming into the ready-mix concrete business to give green concrete to our customers. In Pune, we are yet to come, but there are plans. These are our cement products, slag cement and composite cement. Last but not the least, I'll just take another 2 minutes to cover about slag sand. This is a slag sand. Slag, which is a byproduct of the blast furnace. We are using a crushing and screening operation to convert this particle into a rounded shape and get slag sand. As per the IS 383, this classifies under iron slag aggregate of IS 383. So this is a wonderful material for concrete as well as for plaster. It has all the advantages of being a green product, being a recycled product, being a material with zero wastages and zero impurities, and available throughout the year. Unlike river sand, which has a lot of impurities, it is controlled by mafia, it damages the ecosystem. So again, it classifies under the green product. It has the required physical properties of the river sand, but it comes to you as a green product. And before we started selling it, we have also used it in our steel plant in a lot of heavy applications where heavy loads come on the warehouse flooring and other applications. Not only ourselves, but there have been national highway projects where they have used slag sand in all the three applications, GSB, DLC and PQC. So this is what I wanted to present. Thank you for this opportunity. Look forward to working with you to make concrete more green. Thank you so much.
Thank you very much, sir, for this informative session. We have learned the new words slag and GGBS. Many of the students are getting insight from this. Now it is time to felicitate our special guests for today. And as special guest, we have received the presence of Professor V.R. Phadke, sir. Recently, there was Teachers' Day celebrated on 5th September, and we are very obliged to have the teacher over here because a teacher entirely surrounds the society, develops a person, a human being, and cultivates an engineer into a society useful product. So we are really happy to receive your presence, sir. I would like to read information, or we can say a brief introduction about Phadke, sir. Professor V.R. Phadke, former faculty and head at renowned engineering colleges. Professor Phadke obtained his Masters in Civil from College of Engineering Pune, COEP, and has an on-site experience of more than 26 years. He has served in military engineering services for 8 years, wherein he has carried out field and lab tests required for soil exploration and served as quantity surveyor. He has worked as senior technical officer in ECIL for 8 years and was associated with setting up communication link along the Indo-Pak and Indo-China border in Gujarat, Rajasthan and Assam, consisting of construction of foundation, fabrication and erection of antenna towers requiring high precision. Sir has served as a manager and a project manager in HCC Limited for 8 years again. Then he contributed to construct tunnels, bridges, powerhouses in the state of Tamil Nadu and Himachal Pradesh. Sir has teaching experience of 26 years, wherein he has served the MIT College for 17 years and he has worked with Rajshri Shahu College of Engineering for 9 years. He has co-authored 5 textbooks in various subjects like Material of Construction and Concrete Technology, Building Construction, Geotech Engineering, Foundation Engineering and Infrastructure Engineering. He was also felicitated by the hands of Honorable Shri Nitin Ji Gadkari Sir, Minister of Transport, for the work done for IIB, that is Indian Institution of Bridge Engineers. Along with IIB, Sir is an active association with Indian Concrete Institute, Indian Geotechnical Society, Indian Forest Society, wherein he has served as Honorable Secretary of Pune chapter for all these 3 associations. I am very proud and honored to have you, sir. I request Engineer B.B. Padasni, sir, to please felicitate V.R. Phadke, sir. A huge round of applause. A very, very warm welcome, sir. Thank you very much, sir. Now I request Honorable V.R. Phadke, sir, to please have this words of wisdom with the gathering. Students, please be seated.
Immunity on the dais, on the dais and off the dais. Various faculty members of this college and student friends. I am extremely thankful to ICR and this college for giving me this honor. I am quite aware there are not many engineers present in this audience only who have contributed more than me. Yes, more than me. But still I am honored. So it is a big honor to me. They are young in age by me. But as far as experience and other things are concerned, they are far ahead of us. I am very thankful for giving this honor. Because I have been given this chance, I would like to express some opinion. I was a professor in 2 colleges, and many times it is said that there has to be cooperation between industry and institute. That's only is said. but it is not done. That is a really bad problem. But compared to the earlier scenario, the things are changing quite fast. In olden days, there were hardly any more institutes like ICI, IIT, and so many several. There were only 2 or 3. But now, the technology has increased and number of institutes making this thing is also increased. On olden days, there were only 4 or 5 colleges. But now there are, in Pune itself, there are 30 colleges. Yes, the number has increased. But sad part is that we are not able to channelize the tremendous energy that the students are having. Energy cannot be stored, it has to flow. And if we do not channelize this energy, perhaps it may go in the wrong direction also. So, unless and until there is a proper coordination between industry and institute, it is not going to make changes. My personal experience is that industry is tremendously helpful to the institute. Yes. Yeah, I will quote about 15 to 20 companies in which I have gone to them and they have helped me. For example, L&T, SCC, Apicons, and a very large number. They have never hesitated in giving their cooperation. It was the defect of the technical institutes who have not approached it. See, there is the best laboratory, soil mechanics laboratory in India, it is in Pune. But hardly, very few colleges are taking advice in this service. This is not a good thing. And they are very eager to help. They are very eager to help. See, the students have a tremendous interest. For this student only, they were hardly expecting, say, 300 or 400, I said 500 participants. But now it has gone to 2,000. They are, we continue to manage. There is a very good chance. There is a very good chance. My only appeal is that this energy which the students is having, it is required to be channelized properly. The students themselves should ensure that they join various institutes, participate. And unless they get proper training, they will not go further. I wish all the students very best. They should insist their faculty members to take them to the industry, invite them. They do come. They do come, they help too much. Not too much, but they help very much. I'm sorry for using the too much, because that would mean that it is not necessary. Anyway, I am extremely thankful for ICI for giving me this one. Thank you.
Thank you, sir, for your golden words. We are sincerely grateful to you, sir, for your presence and sharing your valuable experiences with us. Today, we are honored to have our another special guest, Honorable Dr. Rajiv Krishnani, sir, owner and founder of Messrs. R.B. Krishnani. Sir is running a civil construction firm, Messrs. R.B. Krishnani, since last 45 years. Presently, Sir is director and trustee of AIMS Hospital, out Pune. Sir has a specialization in construction of water retaining structures, water treatment plant, sewage treatment plant, and sewage pumping stations. The quality of water served from these plants are certified to the agencies that the quality of water is better than the distillery water. We proudly add that the Colombo University awarded a doctorate on the subject of water purification and economical cost. Such sperm is also applied in IMCA book of awards for an individual constructing the maximum number of reservoirs works. Such company R.B. Krishnani has constructed more than 500 reservoirs including design and construction of 3 crore liter capacity single elevated reservoirs. They have also designed and completed 2 major water treatment plants of 120 million liter daily under PCMC Pune. Krishnani sir has been graced with the Golden Citizen of India Award by National and International Compodium of New Delhi. They have also received Jal Ratna Award in Mumbai, also awards in Builder Association of India, and many more excellence awards have been given to the Messrs. R.B. Krishnani sir for the tremendous contribution to the construction industry of India. Today it is my honor to request Honorable Dr. Raju Krishnani sir to please. I kindly request respected engineer Hemant Joshi sir, Executive Committee member, ICL Pune, to felicitate our special guest honor, Honorable Dr. R.B. Krishnani sir, owner and founder of Messrs. R.B. Krishnani. We welcome you, sir. Dr. R.B. Krishnani, sir, owner and founder of Messrs. R.B. Krishnani. Students, please be seated on your places. We warmly welcome you, sir.
consistent setting aims. And second one, we can say construction joints. In construction projects, sometimes during concreting, we neglect about the construction joints, but construction joints are a common weak point in the structure where water will often find its way in and through it. Corrosion of reinforcing steel from water penetrating through the joints can cause damage to our structure. Planning for and using controlled joint locations can help avoid random cracking. Thus, we are to make sure that each joint employs a reliable waterproofing system of its own. The best long-term protection at joint location is due to a joint waterproofing system includes the crystalline technology which self-seals the random cracking and thus provide the added reliability and protection. Thirdly, prevent premature moisture loss during placing of concrete. Keeping the concrete moist and at an adequate temperature helps to provide proper hydration of the cement for maximum strength and increase the density and lower permeability and greater resistance to scaling. We should pay special attention to placing and finishing. Often, excessive or premature finishing can lead blistering and reduce the surface air content and durability, thus affect durability. So adding water to concrete during toweling increases the probability of surface scaling and swelling. The increase in water-cement ratio at the surface weakens and concrete at the near surface cohesion. It is better to use an evaporation retardant in rapid moisture zone in moisture loss conditions to prevent the surface crusting and plastic shrinkage or cracking. Next is low permeability. We may have to adjust the mix design to match the condition, but there is one factor that is common to all concrete, that is low permeability. For low permeability, good mix proportioning by reducing the amount of the water in our mix and using water reducing admixtures or plasticizers is essential. A waterproofing admixture should be used to protect the concrete from the water intrusions. And next, proper curing. Proper curing means the maintaining the conditions that will allow the concrete to harden and gain strength optimally, and this step is central to extending the life of our concrete. Proper temperature and humidity are the most important. The temperature should be above 10 degrees Celsius for stem development to proceed at a reasonable pace. So it is critical to maintain proper moisture levels the first few days for cement hydration and also to keep the concrete from drying, shrinkage and cracking. And next is protect concrete from de-icing salts after curing. Frequent wetting and drying during the early age of concrete will cause cracking, scaling and lower concrete strength and increase the possibility of scaling. It is essential that the concrete be protected from freezing temperature during the first days of hydration, and when its low strength or high moisture content make it most susceptible to freeze or thaw damage. Where the presence of glacier agents cannot be eliminated, treat the surface or with something like aquapel to prevent the migration of nearly 90% of glacier salts and effectively repel a high percentage of moisture that will cause deterioration. Lastly, concrete placement. Concrete must be placed properly, consolidated into a solid mass that is free from any voids or rock pockets. Avoid voids below the behind reinforcing steel bars and hydrate all concrete with a special attention around the congested reinforcement, and there should not be standing water flow to concrete for placement. Actually, Sergeant Ma'am, I got opportunity to work in Konkan Railway in JNK, and I completed a tower up to completed a pier up to 3.3 meter height, and there we sleep from. And there in JNK, by the time we have controlled like we have done competing in -3 degrees also, sometimes -2 degrees, sometimes 4 degrees, like that. Yeah. And I also got best quality award for Afghans. By the time I was working with Afghans in infrastructure in Delhi, and I got the best quality award for Barbara Library in Afghans. And lastly, during my tenure at L&T, sir, I got opportunity to work with the longest giver bridge in India. That I have done almost 442 piles of 2.5 meter diameter, 54 meter depth, and within a year before joining in Pune Metro. So lastly, I thank you all, and especially organizing committee and Indian Concrete Institute Pune for giving me the opportunity to be with to take part of this concrete event. Thank you.
Thank you, sir, for your golden words. We sincerely appreciate the time you took for our event. We are really grateful for your thought-provoking speech and valuable experiences shared with us. Thank you, sir. Now, we have reached the end of the Concrete Day event, 14 September 2022. Hence, I like to request respected engineer Hemant Joshi, sir, Executive Committee member, ICI Pune Center, to please give the vote of thanks of the Concrete Day event.
Hello. So, good evening. To those people who had remained over here with us, thank you very much. First of all, to you people. And also we should thank to the people who played here that musical chairs. Okay, fine, no issue. So, well, I'm here to give a vote of thanks, and my first thank would go to Mr. Datta sir. We would like, Datta sir, that you should involve more in ICI and colleges. So you should find time, like you have found the time today. We will be very happy to receive you in ICI. And I really thank you that you are here and you have given some few words of advice, nice advice about the concrete. I also thank our principal sir, Sunil Thakre sir, Dr. Sunil Thakre sir. He had given us all opportunity, all college at our disposal. And because of efforts from his staff, from his all faculties, everyone, that some big gathering of students that has happened properly without any I would say any sort of restraints. Okay. I also will like to thank Yusuf. It was his dream. We must have students, and we will work for the student, and that is what he did. I will also thank our ICI committee members. They have supported wholeheartedly, given free hand to us. Also. Okay. And also our people who have contributed to our exhibition. Trivikram sir, it's very nice to see you again after a long time. And many people were there. They were stationed there. Rains, sun, whatever it is, wind, everything. They took it. They did a nice job. They assembled things, and that will still remain tomorrow also. So many people who want to see the things, they can visit tomorrow again. And lastly, I think anything is missing. Sponsor, yeah, so you're very right. Sponsor, I should be very thankful. Because of them, this could happen. Without the sponsoring, I think it is rather it is very difficult for institute like ICI that they can head such a big program over here. So sponsors are really very helpful. We wholeheartedly thank them. And lastly, and very lastly, not the least one, I should thank our Almighty Rain God. It helped us a lot today. Okay, so like Lover is saying, Lover बोल रहा है कि ए बारिश जरा थम के बरस, ए बारिश जरा थम के बरस, उसे आने दो, फिर ऐसा बरस कि वो जा सके. So I will request Rain God, ऐसा बरस कि यहाँ से कोई जा सकता है. कल का पूरा दिन है, लंबा दिन है, and your Josh I want over here tomorrow. So thank you very much. Thank you very much.
Thank you, sir. Generally, the introductory speeches are refreshing. I've experienced a vote of thanks which was refreshing. Thank you, sir. Now we have reached the end. With prior permission of our today's honorable chief guests and dignitaries, we declare the end of the event, Concrete Day. With the same enthusiasm and decorum, we are awaiting to experience tomorrow's day, which is Engineers Day, and followed by the competitions. We will all gather here again at 4 p.m. To the sponsors, there is a small notification. The representatives from the sponsoring organization, please meet Harshal Madam before leaving. Thank you very much. Thank you, one and all.